Hello, everybody. We are doing lesson 11.2 today. What's a polyhedron? Okay. And you will find that under modules, unit 11, 11.2 notes. Okay. Just a reminder, you guys can pause this, fast forward, rewind, if I'm going too fast or too slow. But there's lots of new vocabulary in here, so you want to make sure to pay super close attention. These notes will be submitted to me when you're done writing them out. Okay, so, and also thank you very much for your patience with me. This last month, it's been kind of crazy, and I super appreciate your patience and your grace with me, so thank you. All right, so let's get started. 11.2, what's a polyhedron? Okay, so a polyhedron is a three-dimensional object made from polygons. Okay, so you're going to look at all different kinds of polyhedrons. We're going to talk a lot about what are called prisms. We'll talk about pyramids today. Okay, and so let's get started. Okay, a polyhedron is a three-dimensional solid bounded by polygons, and those polygons are called faces. Okay, and those faces enclose a single region of space. Okay, so if you look down below at these pictures down here, those are polyhedrons. Okay, but we very specifically call them prisms. Okay, and we'll get to that in a second. So every polyhedron is made up of the following three things. Every polyhedron has what are called faces. Okay. The faces are the plane figures that make up its surfaces. And if you remember from Monday, plane figures are two-dimensional. Okay, those are two-dimensional figures. Okay. Polyhedrons are also made up of what are called edges. Okay. Edges are line segments that are bordering each face. Okay. And lastly, a polyhedron is made up of vertices. Okay, and vertices are points at the end of each edge. Okay, and we're going to label these things at the bottom or next to the pictures below. Okay, now a prism is a polyhedron with two congruent and parallel faces, and those faces are called bases. Okay, that's really important. They are congruent and they are parallel. The other faces are called lateral faces. Okay, and all of the lateral faces, okay, they are rectangles. Okay, the lateral faces are rectangles. Now, this is very, very important. You name a prism by using the shape of its bases. Okay, you name a prism by using the shape of its bases. So what does that mean? Well, let's look at these two pictures. Okay, both of these are prisms, okay, and they are right prisms, and I'll tell you why they're right prisms in a minute, but they are both prisms. Okay, this blue box is pointing to bases. Now remember, bases are congruent and parallel. So this and this that I just highlighted, those are two pentagons. They are congruent and they are parallel to each other. Okay, so those are our bases. Now in the second picture, these guys, this blue box is also pointing to the bases. These two bases are triangles. They're congruent and they're parallel. Okay, now remember, I told you that a prism is named using the shape of its base. So the one on the left, I told you it's a pentagon or that the bases are pentagons. So this is called a pentagonal prism. Okay, it's a pentagonal prism because the base is a pentagon. Whereas the figure on the right is called a triangular prism because the bases on the right are triangles. Okay. Now, for both of them, if you notice, I'm going to highlight this. In here, it's yellow there. Okay, it's yellow here. All of these, okay, all of the things, all the shapes that you would see if you were to turn that figure, okay, you're looking at rectangles. Okay, those are all rectangles, and all of those rectangles are called lateral faces. Those are lateral faces, and they're always going to be rectangles. No matter what shape the base is of a prism, those lateral faces are always rectangles. Okay. Now, each prism has an altitude, okay? And the altitude of a prism is a perpendicular segment that joins the planes of the bases. Joins the planes of the bases. Okay, so what does that mean? If I'm looking at this pentagonal prism, this pink line that I'm drawing in, okay, it connects both of those bases, okay? And if it had a 90-degree angle there, you would know that it was the altitude. It doesn't, I just drew that in. But it connects both of those bases, okay? Now, the height, or h, the height of a prism, is the length of that altitude, okay? Now, I mentioned a second ago that a prism, the prisms above are called right prisms, okay? You can have either a right prism or an oblique prism, okay? They can be right or oblique. So just like in a right triangle, you have a 90-degree angle, the same is true in a right prism. So these on the left, these are right prisms, okay? Notice this guy is a rectangular prism because its bases are rectangles, okay? And this one on the right, that is a trapezoidal prism because its bases are these trapezoids. Okay, now some of you are probably thinking, well, wait a minute, why is that? Why are those two the bases? And why aren't some of the rectangles the bases? Well, remember, in a prism, the bases are two congruent and parallel polygons. Okay, so none of those rectangles are congruent or parallel to each other. Okay, so now let's look at these on the right. These are oblique prisms. And they're oblique because they're kind of slanted. They're like crooked, right? And to measure the height, you would have to go outside of it. Or you could go inside of it, right? But it would have to form a 90-degree angle. Okay. So the oblique prism on the left, again, is a rectangular prism. And then the one on the right, this guy, is a triangular prism. Okay, because the bases are triangles. Okay. Now, in a right prism, the lateral faces are rectangles. Whoops. The lateral faces are rectangles. And a lateral edge is always an altitude. Okay, an altitude. So in the right prisms, the ones on the left side, okay, over here, the lateral faces, these are all rectangles, right? However, in oblique prisms, they're not rectangles. They're slanted, right? So these are parallelograms and they're not rectangles. They're less specific, okay, because they're slanted. One other thing I want to mention that I did not write in here is that any polygon can be the base. Any polygon can be the base of a prism. Any polygon. So we've seen above, we've seen triangular bases, we've seen trapezoid bases, we've seen pentagon bases, we've seen rectangles as bases. You could have any polygon as a base, okay, for a prism. Okay. All right, now, if you look at this next picture right here, this is a picture of a triangular prism because the two bases are triangles. Okay, now it's showing this yellow like slice going through that triangular prism. Okay, that slice is called a cross section. Okay, it's called a cross section. And a cross section is the intersection of a solid and a plane. Okay, and I like to think of a cross section as a very thin slice of the solid. Think of like a slice of bread, okay? And you were to cut through that loaf of bread and open it up, and you would see, the inner shape of this. So this over here is a cross section, and it has the same shape. It has the same shape as its base. So because this is a triangular prism, the cross sections are all triangles, okay? The cross sections are all triangles. Okay, so that's all the vocabulary for a prism. Okay, now we're going to talk about pyramids. And I think most of you have seen pyramids before, right? Like the Great Pyramids in Egypt. Okay, we've seen them in pictures for sure. Now, a pyramid is a polyhedron in which one polygon, the base, can be any polygon again, and the other faces, also called lateral faces, are triangles. Okay, and those triangles meet at a common point called the vertex of the pyramid. Okay, so the difference between a pyramid and a prism is that a pyramid has only one base, one polygon base, whereas a prism has two, okay? And because it only has one base, all of the lateral faces are triangles, okay, and not rectangles, okay? Just like in a prism, though, we name a pyramid by the shape of its base, okay? We name it by the shape of its base, so it might be a square pyramid, or a triangular pyramid, or a hexagonal pyramid, which is made of a hexagon base, okay? And then we also need to know that the altitude of a pyramid is the perpendicular segment from the vertex to the plane of the base, okay? From the vertex to the plane of the base, and we'll explain this in the pictures below. The length of that altitude is the height of the pyramid. Okay, so height and altitude are one and the same, but understand that it has to be perpendicular. Okay, now a regular pyramid, okay, the word regular, I hope you remember, means all sides are congruent. Okay, so a regular pyramid is a pyramid whose base is a regular polygon. Okay, so a regular pyramid may have a square as a base, or an equilateral triangle as a base, or a regular hexagon as a base, or a regular pentagon as a base, okay? And all of the lateral faces, all of those triangles, they're congruent, okay? So in a regular pyramid, it's a pyramid whose base is a regular polygon and whose lateral faces are congruent triangles. They're all congruent triangles, okay? One more thing that I'm going to mention today that I don't think Apex mentions, but I wanted to make sure to put it in here. Apex will mention it later. It's about the slant height. Okay, and they call slant height S. And slant height is the length of the altitude of a triangle of the pyramid. So of the lateral face. Okay, and I'm going to show you what I mean by that here in a second. Okay. Now, above, we talked about cross sections of prisms, okay? And something I didn't mention up here, let's go back up here for a second where I just highlighted. It says the cross section has the same shape as its base. I should say same shape and size. Those cross sections are all going to be the same size in a prism. Okay. However, now backing down here, I'm going to add one last thing, is a pyramid has cross-sectional shapes, taken parallel to a base that are similar that are similar but not congruent to one another. They're similar to one another but not congruent. So they're the same shape, but they're not the same size. Whoops. I want you to think of, if you're looking at this pyramid that I'm highlighting, okay, and you were to take cross sections. So all of the cross sections are going to be these squares, but as you get higher to the top, those squares are going to get smaller and smaller, right? So that's why those cross sections are similar but not congruent. Okay. So now we're going to label this left pyramid. Okay. So I'm going to zoom in. This left pyramid, if you look at the base, it has 6 sides. Okay. So because the base has 6 sides, this is going to be called a hexagonal pyramid or a hexagonal pyramid. Okay. It's a hexagonal pyramid. The very tippy top, that black box, is pointing to the vertex of the pyramid. It's where all of those triangles meet. Okay, where all those triangles meet. Then below the vertex in the green box, it's pointing to this yellow highlighted side. Okay, and that yellow highlighted side is a face. And notice all of the faces are triangles here. Okay, all of them are triangles. And they all are in every pyramid. Okay, then the orange box is pointing to the altitude. We know it's an altitude because it comes from the vertex down to the base and it forms a 90-degree angle. Okay, so it goes from the vertex to the base, forming a 90-degree angle. Okay. Now lastly, this blue box down below is pointing to an edge, as is this purple box on the top left. It's pointing to the edges. All of these lines, all these sides of triangles or hexagons, those are edges. Okay, those are all edges. So now let's look at this guy on the right. Okay, I'm going to call this a square pyramid. And I realize as I write this, it doesn't show you that those sides are congruent. Okay, but I'm going to tell you they're congruent. It's a square pyramid. This top left orange square is pointing to that H, which is the altitude of this pyramid, okay, because it comes from the vertex down to the base and it forms a 90-degree angle. That makes it the altitude. Now this other box, I'm going to make this little guy an S, okay? And this is pointing to the slant height. The slant height. And up above, I told you that a slant height is the length of the altitude of one of those triangles of that pyramid. Okay, so if I take this yellow triangle that's highlighted in yellow on that paper, okay, this height here, that is the height of one of those slanted triangles. It's not the height of the pyramid, it's the height of that triangle. We call that the slant height. Okay, it's the height of that triangle. It is not the height of the pyramid. Okay, and that's called slant height. Okay. And then lastly, we've got this pyramid down here. Notice it's kind of like tweaked. It is slanted. This guy is an oblique pyramid. Okay, it is oblique because it is slanted. It's like somebody smashed it. Okay, notice here the height is on the outside of that pyramid. Okay, it is going to the plane. All the heights are the same. They go from the vertex to the plane containing the base. Okay, so that's the plane containing the base. Okay. So this section is just lots of vocabulary. Okay, it's getting you ready for all of the formulas that are coming up next week. Okay, we're going to have more vocabulary on Friday. You are going to have to submit these notes today, completed notes, in the spot that says 11.2 notes, okay, in assignments. All right, thank you so much. If you have any questions, email me. I will not get back to you today, but I hope you all had a great day.